Regions Review video number 4. So in this video, we're going to deal with the ability to answer these some different types of volume questions. So this first one here is dealing with a volume situation where it's a combination of more than one three-dimensional figure. In this case, we have a rectangular prism, which is the bottom portion of the screen, along with a pyramid, which is the top portion of this little canopy that they got going on here, or this tent. So one of the things that I like to do is just to kind of write myself a little bit of a note. So to find the overall volume here of this, we're going to have to find the volume of what we refer to as a rectangular prism, plus we're going to have to do the volume of the pyramid. Okay, so let's find each one individually, and then we can add those things up together. So for this first part here, volume of the rectangular prism, which is this piece here, we're going to deal with its length, its width, and its height. So the length and the width are the same in this case, because it's a square base, and then the height. So in this case, we've got length times width times height. We just said that the length was 8, the width is also 8, and in this case, the height is 9. So when we multiply those all together, that gives us 576. So that would be 576 cubic feet in this case. For the pyramid portion, right, that volume formula, if you remember, is 1/3 whatever the area of the base is, which is the big B, times the height. So in this case, this part here, that's the area of the base, right? Whatever that is, in this case, we have the area being this portion here, would just be a square. So we've got the side, so I'm going to say S squared for the side, and then whatever the height of the pyramid is. So for this one, again, this is the same thing as down here because it's a rectangular prism here. So that's 8. The width of the base is also 8, right? So since it's a square, which you're going to have 1/3 the 8 squared, and the height, which in this case is 3, because that's this part up here. All right. Let's multiply that together. I would make my life easier. 1/3 times 3 is just 1. So really, this just becomes 8 squared, which is just 64. So once again, now to find the actual volume of this entire thing, I can take the volume of those two things. If I add them together, that's going to get me the total volume, which in this case would be 640, again, feet cubed, because we were dealing with units of measure for a volume. So it's cubic units. That gives me an answer choice of B. All right, next question. If we're looking for here the volume of this cone, where they tell me the radius of the cone is 2.5 and the slant height that is 6.5. So key phrase here is that we have a slant height. And we notice that it's a slant height because that's the distance from the top to along the side. Right, for us to do a calculation here for the volume of this cone, I would need to do the formula, which of a cone is 1/3, again, big B times H, again, big B being the area, right? This is the area of the base. So for this case, that would be a circle. So we got 1/3 pi r squared times H. So again, the key here is H. H is the height. I don't have that, right? This right here, this is my height. This is my H right now. I don't have that. So I can't calculate this volume without it. So I have to kind of go off to the side and figure out a way to kind of come up with that. Well, hopefully, if you can see here, whenever we're dealing with a height, we always know that that's 90 degrees with the base. So I have a right triangle here, right, with a height of H, a radius here of 2.5, or in that case a base of the triangle, and a hypotenuse of 6.5. So I can utilize the fact that I have a right triangle here to calculate what the height is. So we can use Pythagorean Theorem. So I'm going to go off to the side here, plug in the Pythagorean Theorem and plug in the appropriate piece of information. So again, A and B are interchangeable. That's just the legs of my triangle. So in this case, I'm going to call it h squared plus b squared, which is 2.5, and the hypotenuse, which is 6.5 squared. All right, so when I calculate that, we're going to have h squared plus 2.5 squared is going to be 6.25. 6.5 squared is going to give me, what is that, 42.25. If I subtract that 6.25 from both sides, that allows me to get h squared by itself. That's going to give me 36. And if I actually take the square root of both sides, that will leave me just a single h, and that's going to get me plus or minus 6, but again, we're dealing with a length here, so the negative's not possible, can have a negative distance, so therefore h is in fact 6. So once I have that portion, and I now know that this is equal to 6, now I have a height that I can actually use to calculate the volume. So if we go back over to our formula over here, we've got 1/3 pi times 2.5 squared times, in this case, my h, which we just found to be 6. Once again, I would try to make my life a little easier here. 1/3 times 6 is just 2, so it's going to be 2 times whatever 2.5 squared is, right? In this case here. Now, also, while I'm doing this, I wouldn't just throw all of this right into my calculator, because look at my answer choices. I've got pi in all of my answer choices, so we're just going to leave pi in our answer. So if I multiply these all together, all right, 2.5 squared, that's 6.25 times 2, it's going to get me a 12.5 pi for the volume. So that would give me choice A as my answer choice. All right, so again, just got to utilize the information that they give you. You got to be careful that you don't just jump in and just plugging in whatever's in the question. You have to make sure that the information they give you is appropriate for the volume formula that you're trying to use. The other thing you want to make sure you do, and you'll see this in other questions, is just make sure the units are the same. So here we've got centimeters and centimeters, so I was able to do that. Sometimes they give you like centimeters and inches or something like that, or two different units of measure, and you got to convert them so that they are the same. All right, let's move on to the next one. So this other question here is a little bit more lengthy, more involved. We've got Teresa has a rectangular pool and 30 feet long and 15 feet wide and 4 feet deep. Teresa fills her pool using city water at a rate of 3.95 per gallons of water. Nancy has a circular pool with a diameter of 24 feet and a depth of 4 feet also. Nancy fills her pool with a delivery service at a rate of $200 per 6,000 gallons. So if Teresa and Nancy both fill their pool 6 inches from the top of the pool, determine and state who paid more for the pool. So lots going on here. So definitely going to help you out here to just kind of give yourself a sketch, see what's going on right here. So let's start off with Teresa. All right, so a couple things here. So this is going to be Teresa over here. So first off, we've got a rectangular pool, right? So we've got a rectangular prism. Just give ourselves a sketch. Doesn't have to be perfect, right? We've got a length of 30. We've got a width of 15 and a height here of 4, a depth of 4. Okay. The other thing that's important to note is that she's got a rate going on. Let's give this a highlight here. She's got a rate of $3.25 per 100 gallons. All right, so for her, that's $3.95 per 100 gallons. All right, so let's keep note of that. So the other thing that's important, and they kind of make it a little tricky because they don't put it in the beginning, they put it down here. It says 3 reasons both fill their pools 6 inches from the top. So if we've got the water line here, let's just demonstrate it like this. That's 6 inches, right? So that means it's no longer a depth of 4. The water is not 4 feet deep anymore. The water would only be 6 inches less than that. So that means I'm going to have a new depth of 6.5. I mean, sorry, 3.5. So when we go to calculate the volume here, since it's a rectangular prism, that's going to be length times width times height. So we've got the length of 30, the width of 15, and again, the height here, that's the part that gets a little tricky. It's now this height minus the 6 inches. So that's going to be 3.5, right? Because again, I have to have everything in the same unit. So I'm dealing with feet for all of these, so I got to make sure that I'm calculating it properly. Let me just fix that, make sure it looks like it's an actual 30. Okay, so when I multiply this all together, that gives me, what, 1575, and that would be feet cubed. Now, that's the volume, right? But we need to figure out how much it's going to cost her, right? So I need to convert the cubic feet to how many gallons, because this rate they gave me was the price per 100 gallons, right? So if I do a little bit of a conversion here, right, they gave me this information that 1 cubic foot is the same thing as 7.48 gallons. So if I take that, I'm going to make it as a fraction here. So 1 cubic foot is the same thing as 7.48 gallons. So if I make a proportion here and say, well, the 1575 cubic feet that we just calculated would be how many gallons, all right, over here. So if I figure out what that would be, I can basically make a proportion here, which allows me to cross multiply and solve. So when I cross multiply, I just get 1 times x. So the portion here is just going to be x equals. And when I multiply 7.48 times the 1,575 cubic feet that I get, that gives me a 11,781 gallons. Okay, so that's how many gallons she's used from here. So to find the cost, we can now go back to our rate over here of $3.95 per 100. So I'm going to actually convert that as well and say, well, that's how much it would be for just 1 gallon. So if I take that here, that's going to get me 0.0395, right? If I take those numbers and calculate them out. So now if I actually take this number and multiply, let me write it underneath here, make it a little easier. So if I do 11,781 gallons, and I multiply that by the rate, which we just said is 0.0395, right? That's going to get me the actual cost that she had done, and that comes out to, let's see, $465.35. Again, it's money, so we automatically round off 2 decimal places. So that's how much Teresa has spent on hers. And again, this, if you're not sure how to get that 0.0395, I just divided it because I want to know what it would be for 1 gallon, just to make it easier to multiply by. So this is what's going to cost Teresa. So now we got to kind of go back, kind of start all over and do the same kind of a thought, but now we're going to do it for Nancy. All right, so Nancy's got a circular pool, right? So her pool is going to look something like this. All right, so that's a cylinder. It tells me that we have a diameter, so be careful. We got a diameter of 24 and a depth of 4 feet. Once again, she's got a water line here as well, and that water line is, again, 6 inches below thing. So once again, same thing here. That height, when we go to calculate, is actually not 4. It's going to be 3.5 again. All right, so in terms of our calculation, to find the volume of a cylinder, we've got pi r squared times h. So if we plug that in, we got pi. Again, the radius, we got to be careful because they gave me the diameter of 24. So radius equals the diameter divided by 2. So we're going to have 24 divided by 2. So that's going to give me the 12. So we've got a 12 squared times a height of, and as we just said the same thing, it's not 4, it's really 3.5 because the water's only going up 6 inches below the surface of the pool. So when I go to calculate this, that's 12 squared is 144 times 3.5. That's going to get me 504 pi. Right? Now, again, if I was trying to do something else, I might carry the pi along, but since we're just going to straight go into finding out what the value of the cost is, I'm going to multiply that out so I can get the decimal. So that gets me 1583.362697, blah, 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 blah. So I want to take that entire thing. So leave that number in your calculator, right? So that I can convert it. Just like we did over here, I want to convert how many, again, this is cubic feet. How many gallons would that be? So I'm going to do the same thing I did over here. Make a proportion, right? Ultimately, it's going to be the same exact style. It's 7.48 times the cubic feet that we just found. So if I take this number and I multiply it by 7.48, so I'm going to take that. We're going to get a, this is going to get me a conversion of 11,843.55298, blah, 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 blah. And then again, now we're in gallons. Right, so again, all I did here is multiply by 7.48 again, because again, made the proportion to solve, just like I did off the side there. All right, so now I got gallons. Once again, just like we did over here, I take the gallons, I multiply by whatever the rate is. So in this case, Nancy, if we go back to the top here, she had a rate of, so she's got a rate of $200 per 6,000 gallons, right? So in this case, if I take that 200 and I divide it by 6,000, that's going to get me a value of 1/30th or 0.03 repeating, right? I'm going to leave it as a fraction because it's easier to work with. So if I take my 11,843.55298 and I'm going to multiply that by our rate that we just said, in this case, 1/3. Again, if you do it in the calculator, you get 0.303333, so on and so forth. Again, if you have it in the calculator as that already, you can just multiply it by this number, but that's the same thing as 1/3. And when I actually calculate that, we get, again, it's money, so 2 decimal places, so $394.79. Oops. What happened there? $394.79. So that's what Nancy did. So again, make sure you answer the question. The question says, in this case, determine and state who paid more to fill up her pool. So in this case, since Teresa spent more to fill up her pool than Nancy. All right, so that's everything. It's a long question here, a lot involved, but again, key things to think about are just draw yourself a picture. All right, be careful about the conversions, a lot of little things going on here. And again, the other little trick is that 6 inches, you have to, subtract it off and make it only 3.5 for the ultimately for the height. All right. Hopefully you enjoyed the video, and if you have any questions, let us know.